In this video, we will discuss the concept of variance and standard deviation. To start, let's start out with an example to motivate these concepts. Consider three random variables, w, y, and z. W has only one value, that's 0, and so the probability that w is 0 is exactly 1. Y has two distinct values, -1 and 1, and the probability that y is -1 is half, and the probability that y is 1 is half. Z is another random variable, and z also has two values, -100 and 100. The probability that z is 100 is the same as the probability that z is -100, and both are equal to half. Now observe that the mean or expectation of each of these variables is 0. So what's the expectation of w? The expectation of w is to find the expectation of w, we multiply each value of w by the associated probability and add them up. So the expectation of w would be 0 times p of 0, which is 0 times 1, which is 0. The expectation of y would be -1 times p of -1 plus 1 times p of 1, which is -1 times half plus 1 times half, which is 0 again. And similarly, the expectation of z is 0 as well. Now clearly, if I look at the mean of each of these variables, the mean 0 doesn't tell us how these variables are different from each other. So if you think about these three variables, it seems like they are different in the spread of their values. So that motivates that maybe we need to measure the spread. And so how are we going to measure the spread of a variable, the spread of the values of a variable? So let's let x be a discrete random variable, and let x1, x2, x11, be the values of x. Here mu is the expectation of x, or we call that the mean. Okay. Now for a given value xi of x, xi minus mu will be called the deviation of xi from the mean mu. So one possible measure of spread would be to calculate the average distance from the standard mean. That is find find the average distance of the values of x from the mean. So that means that quantity would be given by the summation over I of the absolute value of xi minus mu times p of xi. So this quantity here, what it is giving us is remember, expectation means average, so this is giving us the average of the absolute values of the deviations of the values of x from the mean. That's a long sentence. So but this is a nice measure. It measures the spread well, but the disadvantage of this measure is that absolute values are analytically hard to work with. So it's hard to do algebra with them. So we use another measure of spread, which is called variance. So the variance of a random variable x is denoted by sigma subscript x superscript 2, or sometimes simply, when the context is clear, we're going to write sigma squared. We also use the notation VAR of x for the variance, and all these symbols mean the same thing. It is the expectation of x minus mu squared, where mu is the mean or the expectation of x. So let's write out the expectation. The expectation of x minus mu squared, if I write it out, it will be the summation of xi minus mu squared times p of xi, where the sum goes over all possible values of I. So what is this? What is this measuring? Well, what this is measuring is average of squared deviations from the mean. Okay, so this is a nice measure. Analytically, it is much easier to handle than the absolute than the measure with the absolute value. So this is the measure of spread that we are going to take. Let me list out the properties of variance, which we're not going to prove, but they are pretty easy to prove. Number one, the variance of a random variable x is the same as the expectation of x squared minus the expectation of x whole squared. So this is right here. It might be more clear to you if I put square brackets here. The notice that expectation of x squared, that's the second moment, and the second term here is the square of the first moment. So this is number one. Number two, the variance of a constant variable c is 0, which is clear. If the value of a variable is always the same, c, then the spread is 0. The variance of c times x, where c is the constant, is the same as c squared times the variance of x. And the variance, number 4, says that the variance of x plus a constant c is the same as the variance of c. So adding a constant to all the values of a variable doesn't change the spread. Number 3 says if you multiply a variable x by a constant c, then it changes the variance by a factor of c squared. Now, standard deviation will be denoted by sigma, and sigma is defined to be the square root of variance. So let me explain variance and standard deviation in the following example. So let's let x be the outcome when a fair die is rolled. Then let's calculate the variance of x. By using property number 1, the variance of x is the expectation of x squared minus the expectation of x whole squared. So this would be like this. So let's find the expectation of x squared. So we replace x by each of its values and multiply them by corresponding probabilities. So plug in x equals to 1, so I get 1 squared multiplied by the probability of getting a 1, which is 1/6. plus plug in 2 for x, you get 2 squared multiplied by the probability of 2, which is 1/6 again, plus 3 squared times 1/6 plus 4 squared times 1/6 plus 5 squared times 1/6 plus 6 squared times 1/6, and those are all possible values of x. So that's the expectation of x squared. Now what is the expectation of x? Well, we have the values of x 1 up to 6, multiply them by their probabilities and add them. So 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6, and if we do the arithmetic, we get 91/6 minus 7/2 squared, which is going to be 35/12, and that's about 2.92. So that's variance. And if I want to find the standard deviation sigma would be the root of 2.92, which is about 1.71. Okay, so that's the standard deviation of the variable x. Now what I want to do is I want to also calculate the variance by using the so we found the variance by using the property number 1, but let's find variance by directly using the definition, which is so we are talking about this. So let's use this formula for variance. So in order to do that, I need to find the expectation of x, or the mean. So we actually already calculated the mean. Notice that the quantity here is actually the mean of x, right? Because that's the expectation of x. So that we know that already is 7 divided by 2. So we know that the mean is 7 divided by 2. So the variance sigma squared would be the sum. Okay, so here from each value, sum over all values of x, and from x you subtract the mean and you square it, multiply by the probability of x. So that's the variance definition. So here now the possible values of x are 1 up to 6. So when x is 1, so 1 minus the mean is 7/2 squared times the probability of 1 is 1/6, right? Plus I have x has the value 2, so 2 minus 7/2 squared times 1/6 plus 3 minus 7/2 squared times 1/6 plus 4 minus 7/2 squared times 1/6 plus 5 minus 7/2 squared times 1/6 plus 6 minus 7/2 squared times 1/6. And at this point we can use our calculator to calculate this sum, but so what I'm going to get though is the following. From the first term would be 2 minus 7, so that's 5/2, so 25/2 4 times 1/6. The second term would be 4 minus the 7, so that's 3, 9 over 4 times 1/6 plus 1/4 times 1/6. The next term would be 8 minus the 7, so 1/4 again times 1/6 plus next term would be 5 times 2, 10 minus the 7, which is 3, 9 over 4 times the 6 plus 6 times 2, 12 minus the 7, which is 5, 25 over 4 times 1/6. And at this point I am just going to factor out 1/4 and 1/6. So if I do that, I get 25 plus 9 plus 1 plus 1 plus 9 again plus 25. And if we add them up, we get, so 25 plus 9 plus 1 plus 1 plus 9 plus 25, so that's 70. And so I get 1/4, 1/6 times 70, which would be equal to, so remember what we got before. We had 35 over 12 before, so 2 goes into 4 twice, and 2 goes into 70 35 times. So I get 35 over 12 again, which we know is about 2.92. Okay, so we get the same answer by using both formulas for the variance. Alright, so I'm going to stop here. I'll see you in the next video.